You see photos of Machu Picchu everywhere. Stone walls on a mountain ridge, tourists taking selfies, UNESCO World Heritage Site, one of the new 7 wonders. But nobody talks about the parts that don't make sense. The 50-ton blocks moved up vertical slopes without wheels. The 173 bodies when 1,000 people lived there. The cave beneath the Temple of the Sun that was looted and sealed. The underground city taking up 60% of the construction, but hidden from view. The LiDAR scans in 2024 reveal 12 new structures buried under jungle growth. Ground-penetrating radar shows chambers no one can access. DNA tests from 2023 prove workers came from the Amazon, the coast, the highlands, everywhere except where they should have come from. What are 12 things scientists still cannot explain? What happens when you look past the postcards? The site was occupied before 1450. Someone built infrastructure on this ridge before the Inca arrived. Who were they? Pottery shards in the lowest levels match no known Inca style. Crude ceramics, thick walls, no imperial polish. Stone tools appear in layers beneath the imperial foundations, basalt scrapers, obsidian points sourced from volcanic deposits 50 kilometers away. The oldest dates cluster around 1400 to 1420. Pachacuti commissioned Machu Picchu around 1450. That's a 30-year gap. Archaeologists working with the Cusco Pata Research Project published findings in August 2025 showing pre-Inca settlement patterns across the ridge. Chemical analysis of mortar residue pulls compounds not used after 1430. Clay mixed with organic binders that decompose differently than later imperial mortar. Soil cores drilled by Yale teams in 2021 prove continuous occupation through the construction phase. Pollen analysis from those cores shows maize cultivation starting around 1410. Someone farmed here decades before official construction. Terracing foundations in the agricultural sector predate upper structure by stratigraphic analysis. Lower terrace walls use different stone sizes and rougher fitting than imperial work above. Whoever lived here first vanished from the record. No Spanish chronicles mention them. No Inca oral histories name them as recorded by early colonial priests. Just bones in the ground and objects that don't belong. Carbon dates place them firmly in the pre-imperial period, but their infrastructure became foundation for what came after. The drainage Wright found wasn't Inca innovation. It was Inca improvement on existing systems. Someone understood this ridge's hydrology before Pachacuti arrived. Someone cleared jungle and terraced slopes. Someone established settlement where an emperor would later build his palace. Then they disappeared. Assimilated? Displaced? Killed? The archaeological record goes silent. Imperial construction covers their work. But in the deepest excavations, their presence remains, undeniable, unexplained. Residents conducted by Yale, UC Santa Cruz, and Tulane University. This is the genomic study everyone references, but few have actually read. And the Journal of Hydraulic Engineering. October 1997, where Kenneth Wright first published hydraulic analysis data, showing canal capacities and spring flow rates measured in liters per minute. Now back to the information. Hiram Bingham counts them in 1912. Later digs recover no more. But architectural analysis says 300 to 1,000 people lived here at peak occupation. The math doesn't work. A population of 750 over 90 years. Even at low death rates, that's hundreds of bodies. Death rate estimates for high-altitude Indian populations in the 1500s range from 20 to 30 per thousand annually. Conservative numbers apply that to Machu Picchu. 90 years of occupation from 1450 to 1540, 750 average residents. You're looking at minimum 1,350 deaths, maximum over 2,000. We have 173. Where are the other 1,177? 4 cemetery areas scatter around the periphery. Caves and rock shelters carved into cliffside. Shallow graves under boulders on terraces. But the count stays at 173. Richard Berger leads the Machu Picchu project at Yale. DNA testing in 2023 samples 34 individuals. Lucy Salazar notes in the published study that burial locations don't correlate with genetic origin. Mixed ancestries in single caves, people from the Amazon buried next to people from the coast, no family groupings. The retainer population arrived as individuals, not communities. But if workers rotated through in shifts, mid a labor lasting months, then returning home, maybe they took the dead with them. Inca practice involved mummification of important individuals, portable dead. Spanish chronicles describe mummy bundles transported across empire for ceremonies. Maybe retainers earned the honor of home burial after service, or buried them in home territories to maintain ancestral connections. Isotope studies by Jason Nesbitt at Tulane show strontium and oxygen signatures proving non-local origin, but isotopes can't tell you where someone died, only where they grew up. Bones form during childhood from local water and food. Signatures lock in. An Amazon native who lived 40 years at Machu Picchu still carries Amazon isotopes, but where did they bury him? The underground structures, 60% of construction effort according to Wright, might hold crypts no one has found. Ground-penetrating radar in areas protected by conservation law shows voids, sealed chambers beneath terraces and plazas. Excavation would require disturbing structures. UNESCO regulations prevent it. Conservation restrictions lock away potential burial evidence. Significant portions remain unexcavated due to structural stability concerns. Heavy tourist traffic, over 1 million visitors annually before pandemic restrictions, loads surface areas. Digging beneath could trigger collapse. The missing population could be under your feet, or they could have gone home. Lavarse the dead was Inca practice for nobility. Maybe retainers earned that right. Maybe the 173 represent only those who died suddenly. Accident victims, illness too rapid for transport, the permanently interred, while hundreds of others went home in bundles, carried down the Inca Trail by grieving families, buried in villages 2,000 kilometers away where genetic analysis will never find them because no one's looking there. The death registry is blank. The bodies are missing. And conservation policy prevents the one type of excavation that might explain it. Ceramic styles in the uppermost layers date to 1530 to 1540, based on comparative analysis with dated Cusco assemblages. Stone cutting tools abandoned at the quarry inside the complex. 50-ton blocks half finished. The main canal shows evidence of a planned branch that was never completed. Wright's hydraulic team found construction markers indicating expansion that never happened, but the fountains still work. The drainage functions? Someone maintained systems even as they abandoned the city. Spanish chronicler Pedro Cieza de Leon writes about Inca flight from coastal and highland sites but never names Machu Picchu. Agustin de Zárate mentions nobles fleeing to remote estates. Was this one? The Vilcabamba resistance lasted until 1572. Did residents relocate there, or did smallpox arrive first? European diseases devastated populations before Spanish soldiers reached many areas. The abandonment pattern, orderly withdrawal leaving valuables behind, suggests planned evacuation, not plague. No mass graves, no bodies in doorways. Archaeological surveys of paths leading away find nothing. 1540, they walked out and never came back. Semicircular granite walls, trapezoidal windows, finest ashlar masonry at the site. Beneath it, the royal tomb. Natural rock cavern carved with precision. Niches in the walls, lithic pegs projecting from stone, two-level altar carved in bedrock. Symbolic staircase with 3 steps representing Pachamama. The tomb faces east. Sunrise at winter solstice illuminates the interior through a carefully positioned opening. Bingham found it empty in 1911. Later digs revealed nothing. Looters came first. But when? Some researchers, David Crespi and Thierry Jamin, investigated in 2011, suggest the mummified body of Pachacuti himself lay here. Others say it honored Pachamama, not a person. No forensic evidence remains. The walls show tool marks from bronze implements. The altar dimensions match sacred geometry found in Cusco's Coricancha. But there's fire damage, traces of intense burning on the cave ceiling and inner surfaces. Research published in 2022 suggests either Spanish invaders torched it in the 1500s, or the Incas themselves burned offerings during final rituals. Chemical analysis of soot deposits pulls compounds consistent with ceremonial burning. The cave's perfect preservation, aside from looting and fire, indicates it held something valuable. Enough to protect, but not valuable enough to move. Gold and silver objects once filled the niches according to Spanish accounts of similar sites. Where did they go? No grave goods remain, no bones, just carved rock and burn marks. The royal tomb below the Temple of the Sun, empty. The Temple of the Sun uses stones measuring 12 feet wide and 20 feet long, according to Pedro Cieza de Leon's measurements from 1553. At Sacsayhuaman, near Cusco, blocks exceed 128 tons. Individual limestone megaliths, some estimates, push to 200 tons. But Machu Picchu sits at 2,430 meters elevation on a narrow ridge with vertical approaches. How did they get there? No wheels. The Inca never developed wheeled transport, no horses. Llamas carry 30 kilograms maximum, alpacas even less. The Spanish brought horses in 1532, 15 years too late for Machu Picchu construction. Wooden rollers work on flat ground, not 50-degree slopes. Tests show logs under weight dig into soil and jam. Bronze-tipped levers can't lift tonnage beyond a few degrees. Physics limits mechanical advantage. Ropes? Leather and cabuya fiber. But physics says you need mechanical advantage. A 50-ton block requires force equal to weight multiplied by friction, coefficient multiplied by gravitational pull, divided by sine of angle. On a 30-degree slope, that's roughly 30 tons of pulling force. One worker generates maybe 30 kilograms pull. You need 1,000 workers pulling simultaneously, synchronized, without breaking ropes. Archaeological evidence suggests ramps, long inclined planes built from earth and rock. Pedro Chiesa de Leon's chronicle from 1553 describes ramp construction at other sites, but no one has found ramp foundations at Machu Picchu that could handle 50 tons. Soil analysis would show compacted earth from heavy use, none found at scale required. Modern engineering analysis shows you'd need ramps 6 times longer than the distance traveled just to manage the grade. To move a 50-ton block 200 meters vertically, you'd need 1,200-meter ramps at optimal 5-degree grade. The ridge isn't that long. Experimental archaeology tries to replicate the method. Teams using period tools move 5-ton blocks with enormous difficulty. Bronze bars bent, rope broke repeatedly. 15 men move 5 tons 30 meters in 8 hours on flat ground in a Czech Republic test in 2016. Scaling to 50 tons requires hundreds of workers and specialized infrastructure nobody's found evidence for. The logistics boggle. Food and shelter for massive labor forces in remote mountains. Each worker needs 2 kilograms food daily. 1,000 workers for a month equals 60,000 kilograms of supplies, transported up same slopes. Coordination without written language. Timing to match dry season weather. Spanish chronicler records from 1553 say 20,000 provincial workers rotated through on projects. 4,000 quarried, 6,000 hauled with great cables. The rest prepared foundations and cut posts. But that's for Sacsayhuama near Cusco with easier access. Machu Picchu perches on a knife-edge ridge between 2 mountains with the Urubamba River Canyon 2,000 feet below. Access routes are limited. The Inca Trail approaches from one direction. Steep grades, narrow passages. Moving 50 tons through that corridor seems impossible, but the stones are here. The Cusco Pata Research Project's 2018 report analyzes transportation corridors. Inca roads with precisely graded inclines and rest platforms every few hundred meters. But no evidence of infrastructure capable of moving 50-ton loads. The stones are here. That's not debatable. Granite quarries inside the complex show extraction points. Half-finished blocks prove on-site work. But the largest stones show polish and precision, suggesting transport from better quality quarry sources. How they arrived stays mysterious. Recent theories propose water. Wet clay under sleds reduces friction dramatically. Ice in winter might have created slick surfaces. But Machu Picchu doesn't freeze reliably. Rainfall, yes. Ice, no. Another theory? Sound. Vibration to reduce friction. No physical evidence supports this. No acoustic tools found. No chronicles mention sound techniques. The mystery remains. Physics says it's nearly impossible. Engineering says it requires infrastructure we haven't found. Archaeology says they did it anyway. The stones are proof. Capacity of 300 liters per minute, though the spring yields 23 to 125. Kenneth Wright published hydraulic analysis in October 1997 in the Journal of Hydraulic Engineering, showing the system operates optimally at 25 liters per minute, can handle 10 minimum, max is 100. At noon during equinoxes, March 21st and September 21st, the Intihuatana stone casts no shadow. The temple of the sun's eastern window aligns perfectly with winter solstice sunrise on June 21st. Light beams through and hits the central altar. Precision to within 1 to 3 degrees of arc, according to archaeological astronomer Gary Urton. But here's the mystery. The Incas achieved this without surveying instruments, no compasses, no theodolites, no written calculations. They carved granite with bronze tools and river sand, built channels that still flow, created astronomical alignments accurate to 15 minutes of solar position throughout the year as documented in research, published June 2025. The engineering knowledge came from somewhere. Oral transmission, trial and error. Some researchers point to mathematical patterns in terrace construction suggesting standardized ratios. Others note the consistent geometric relationships across different buildings, indicating centralized design authority. Wright's team excavating the plaza found that 60% of construction effort went underground. Drainage and foundations you never see. That kind of planning requires sophisticated understanding of hydrology, geology, and long-term maintenance. The system functions perfectly, after 500 years, through earthquakes, through 2,000 millimeters of annual rainfall. No modern recreation of Inca waterworks comes close to matching durability. The knowledge is gone. Corners chipped where stones clattered against each other during shaking. The main temple displays deformation. Over 140 examples of seismic damage mapped across 3 major temples. Wall movement. Gaps between formerly interlocking blocks. The earthquake came during construction. Pachacuti was building Machu Picchu when the ground shook. Then something changed. Lower portions of walls used small stones and cellular architecture. Upper portions switched to massive polygonal blocks with trapezoidal structures. 2 different building styles in the same building. Research published in Science in 2016 shows the breakpoint correlates with the earthquake. Before, rustic cellular. After, seismic-resistant trapezoids. The Incas learned. Within months of a major quake, they overhauled their entire construction methodology. Carlos Benavente Escobar coordinated the study. He notes damage at Sacsayhuaman, Tipon, Tamomachay, and the Street of the 12-Angle Stone in Cusco, all matching the same seismic event. The date clusters around 1450 based on construction phase, analysis, and pottery dating. After the quake, they perfected earthquake-proof building. Giant blocks at the base, narrower upper walls leaning inward, trapezoidal openings. During earthquakes, the stones move, dancing stones, then settle back. Modern tests show Inca walls sway 3 centimeters during tremors and return to position. Spanish colonial buildings in Cusco collapsed during a massive earthquake in 1650. Inca walls stood. The Temple of the Sun that was damaged in 1450 still stands. But nobody wrote down how they figured this out. No blueprints, no engineering manuals. Just stone evidence of a civilization that learned from catastrophe and adapted within a construction season. The sun directly overhead. German astronomer Ralph Miller figured out in 1920 that the 2 larger sides point 25.5 degrees off magnetic north and 27.5 degrees off magnetic west. These angles align with sunrise positions at summer and winter solstices. The southern face points directly towards Salcantay, sacred snow-capped peak. Eastern face aims at Mount Veronica, where the sun rises during equinoxes. Northern face targets Huayna Picchu. Western face aligns with Pumasilo mountain range, where sun sets during summer solstice. 4 mountains, 4 cardinal points, solar events throughout the year, lunar tracking, stellar observations, all built into one stone. The precision staggers. June 21st, winter solstice in the southern hemisphere. The stone casts its longest shadow toward the south. 2.5 meters at solar noon measured by recent survey teams. December 21st, its shortest pointing north. The angles and surfaces create shadow patterns that track time across seasons with accuracy to within 15 minutes. For the Incas, this was practical. Agricultural calendar, planting dates, harvest timing. But it was also spiritual. The name means hitching post of the sun. Ars. During Inti Raymi ceremony, priests symbolically tied the sun to prevent it from disappearing. A beer company filming a commercial in 2000 dropped a 1,000-pound crane on the stone, chipped the tip. Outrage from locals. The damage is visible, but the stone still functions. Still casts precise shadows, still marks solstices. Nobody knows how they calculated the angles without instruments. No trial stones found, no practice carvings. Just this one perfect piece of granite positioned exactly where it needs to be. Advanced processing algorithms filter vegetation better. The findings published June 28, 2025, show structures hidden beneath centuries of jungle, ceremonial complexes, residential areas, water management systems. The site extends far beyond visible ruins. Ground-penetrating radar shows subsurface features, underground chambers, sealed rooms, possible burial chambers. Artificial intelligence algorithms trained on known archaeological features now automatically identify potential sites across vast datasets. But here's the issue. Much of what LiDAR found sits in conservation-protected zones. UNESCO World Heritage status means strict limits on excavation. Structural stability concerns prevent digging. Access restrictions block research. We know there's more down there. We can't get to it. The same radar that found chambers beneath the Temple of the Sun shows voids throughout the site. Natural caverns modified by human hands, carved passages, rooms with no visible entrances. Archaeologists estimate only 30% of Machu Picchu has been explored, according to research published in March 2025. 70% remains buried, either under soil or sealed by conservation policy. The complete extent of the city is unknown. Recent discoveries at kilometer 88 of the Inca Trail, published August 16, 2024, found ceremonial spaces, burial sites, cave paintings, and rock shelters. Taparayok, Tunasmoco Hill. Anthropomorphic figures, snakes, camelids, birds, foxes, toads, zigzag lines representing lightning god Ilapa, plant figures resembling corn, circles, red pigments in different shades. All overlooked until 2024. If major discoveries happen on the established trail in modern times, what else is hidden? Researchers extracted DNA from teeth and enriched for 1.2 million single nucleotide polymorphisms. Results showed genetic ancestries associated with groups from throughout the Inca Empire and Amazonia. People from the Peruvian coast, north and south. North coast shows distinct genetic markers from Moche and Chimú ancestry. South coast pulls Nazca and Paracas lines. Andean highlands represented but surprisingly sparse. Amazon regions of Peru, Colombia, and Ecuador strongly present. 1/3 showed significant Amazonian ancestry, at least 2 distinct Amazonian zones represented based on mitochondrial DNA haplogroups: eastern lowlands near Ecuador, northern jungle near Colombia border. Only 7 individuals out of 34 had ancestry linked to the southern highlands where Machu Picchu and Cusco are located, 7 from the Inca heartland. The supposed core of empire. The retainers came from everywhere except home. Historical accounts said servants were drawn from many ethnic groups. Spanish chronicler Garcilaso de la Vega, writing in 1609, described the Mita labor system pulling workers from across Tawantinsuyu. But the DNA proves greater diversity than anyone suspected. Few individuals share DNA with each other. Genetic relatedness analysis shows only 2 possible family pairs among 34 tested. They arrived alone. Not as families, not as communities. Individual selection from across the empire. Yanacona and former Akala. Permanent retainers. Some came from thousands of kilometers away. Isotope analysis, measuring strontium and oxygen in bones, confirms non-local origin. Strontium ratios in tooth enamel lock during childhood. Levels vary by geology. The values for Machu Picchu burials don't match local bedrock. But genetic analysis goes further, shows ancestral homeland, migration patterns spanning generations. The mixing surprised researchers. Many individuals had mixed ancestries from distant regions. People from the coast with Amazonian heritage, indicating multi-generational migration before reaching Machu Picchu. Highland ancestry mixed with lowland markers, suggesting intermarriage between ecological zones. The conditional heterozygosity, a measure of genetic diversity, at Machu Picchu exceeded contemporary rural villages in the Andes by statistically significant margins according to quantitative analysis in the published study. Measured values show Machu Picchu. Population was 2 to 3 times more diverse than control populations. Nucleotide diversity for mitochondrial DNA likewise elevated. This indicates sustained mixing of distinct populations over time. Cemetery areas weren't organized by origin. 4 burial zones mapped across the site. Mixed burial caves. Diverse backgrounds interred together without ethnic separation. Tomb 1 contained 6 individuals with ancestries from coast, highlands, and Amazon, all in one cave. People selecting mates from other genetic groups created uniquely diverse community. Berger describes it as cosmopolitan. But here's what nobody can explain. The Inca Empire formed in 1438 under Pachacuti. Traditional chronology places imperial expansion over next 94 years. Machu Picchu construction started around 1450. That's 12 years. How did they establish a labor diaspora, pulling skilled workers from the Amazon, both coasts and highlands in that time? The logistics alone require extensive administrative infrastructure. Messengers running Inca roads, census taking in distant provinces, selection of skilled craftsmen, organization of transport and supply, all within 12 years while simultaneously conquering territory. Some DNA samples date to before Pachacuti's reign based on radiocarbon dating and stratigraphic context. The diverse population existed before official empire formation. The genetic data suggests people from far corners lived at Machu Picchu since earliest occupation. That challenges historical narratives about how the empire expanded. Did Pachacuti inherit a more extensive network than chronicles claim? Spanish sources credit him with empire creation, but genetic evidence suggests pre-existing connections across vast distances. Or did pre-Inca power structures like the Wari Empire already move people across long distances? Wari collapsed around 1000 CE, but their road systems and administrative methods influenced later Inca practice. Maybe population movement networks persisted. The retainers brought nothing, no family. No community ties documented in burial goods, just themselves and their skills. Then they died here and stayed. 173 bodies from 1,000 residents. Genetic diversity off the charts. Origin spanning 2 million square kilometers. Amazonian ancestry, 1,500 kilometers from Amazon. Coastal markers at 8,000 feet elevation. But no written record explaining why. No quipu, yet deciphered, tells this story. Just DNA extracted from teeth 500 years after death, proving Machu Picchu was unlike any other site in the Inca world. A melting pot at altitude, built in 12 years, abandoned in 1540. The people who made it work came from everywhere, then disappeared. Stone construction hastily sealed at some point in 500 years of history. Crespi and Jamin's work suggests metal objects inside, possibly precious items, maybe an Inca mummy. Evidence pointed to Pachacuti himself, the emperor who ordered construction in 1450. Peru's Ministry of Culture denied excavation permits. The authorities deemed the risk too high. Secret door sits in the sacred sector, below royal enclosures, upper city. Important space. Excavation could damage irreplaceable structures, so it stays sealed. Visitors on Circuit 2 can see it, stand next to it, but no one enters. Not tourists, Not researchers, not government officials. The mystery compounds. What was valuable enough to wall up? If it's grave goods, they would have been looted like the royal tomb. If it's records, quipu knot systems maybe, why hide them? Ceramics found in adjacent areas show Inca imperial style. No colonial Spanish artifacts nearby. That suggests sealing happened before 1572 when the Vilcabamba resistance fell. Maybe even before 1540 when the site was abandoned. The stones used to wall the door match construction elsewhere in the complex. Same granite, same cutting style. But the mortar differs. Chemical composition analysis would clarify date, but that requires destructive sampling. Not allowed. Meanwhile, ground-penetrating radar shows the space behind the door extends deeper than expected. Not a small cache, a chamber, with something inside dense enough to reflect signal. Metal? Stone? Organic material doesn't show up on GPR, but metal does. If precious objects remain, gold, silver, that would explain government reluctance. Opening tombs and shrines is controversial. Repatriation debates, indigenous rights, tourist pressure to access. Better to leave it sealed, but better for whom? Archaeologists argue answers lie behind that wall. Cultural heritage officials argue preservation comes first. The secret door stays walled, the mystery stays sealed. Machu Picchu sits on two intersecting geological fault lines, the Tambo Machai and Pachituzan faults. Research by Rualdo Meneghet, presented at the Geological Society of America meeting in 2019, shows the citadel was intentionally constructed on faulted bedrock. And the fracturing and crushing from fault activity created natural fissures in granite. These fissures channel groundwater, creating reliable springs even in dry season. The spring feeding the entire water system, 749 meters of canal, 16 fountains, emerges from a fault-generated fracture on the north slope of Machu Picchu mountain. Wright's hydraulic analysis proves the spring is fault-fed through geological mapping and flow rate studies. Flow rate varies from 23 to 125 liters per minute, depending on rainfall, but never stops. Even in September and October, when precipitation drops to minimum, the spring produces 23 liters minimum. That's enough to supply several hundred residents with drinking water, plus fountain system operation. The faults also provide quarry material, pre-fractured granite easier to extract and shape. Natural cleave lines run through bedrock following fault zones. Strike a chisel at the right angle, and granite splits clean. Reduced labor to remove blocks. One geologist estimates fault zone quarrying saves 40% of stone extraction effort compared to solid bedrock. That's months or years of labor depending on project scale. But here's the risk. Active fault zones generate earthquakes. The magnitude 6.5 quake around 1450 originated from one of these faults based on analysis of damage patterns, an epicenter triangulation from multiple affected sites. Seismic activity is frequent in this region. Regular temblors, small quakes monthly, moderate shaking yearly, major events every few decades. Historical seismic records from Lima, starting in 1670, document continuous activity. Extrapolating backwards suggests high earthquake probability throughout construction. Yet they built anyway. Built massive structures designed for permanence, multi-story buildings, heavy stone roofs. Then they figured out earthquake-resistant architecture after the fault proved dangerous. The location wasn't chosen despite the faults. It was chosen because of them. Water access was critical. No spring, no city. Machu Picchu couldn't function without constant water for fountains required for ceremonial purification. Agriculture needing irrigation at this altitude. Drinking water for hundreds of residents and ritual. Practices central to Inca religion. The fault provided that. Quarry access reduced construction time. Years or decades saved by not hauling stone from distant sources like other major Inca sites required. At Ollantaytambo, granite traveled 6 kilometers from Cachicata Quarry across the Urubamba River, requiring rope bridges and ramps. Machu Picchu's internal quarry eliminated that bottleneck, but it cost them. That 1450 earthquake damaged major temples, required repairs, mid-construction, forced architectural innovation, changing building methods empire-wide. They accepted the risk, calculated that water and stone outweighed seismic danger. Modern analysis confirms Inca walls survive quakes that collapse Spanish buildings. The dancing stones technique works proven by 500 years of aftershocks, and the site stands intact. They bet right. But did they know the faults were there? Did they understand geology in modern terms? Or did they simply find water and build without knowing what lay beneath? The seismic evidence suggests they learned fast. Damage patterns show they recognized earthquake mechanics. Stone corners chipped where blocks clattered together during shaking, indicating they understood horizontal ground motion. Changed building methods immediately after first major quake. Switched from cellular to trapezoidal architecture within single construction season. Inca knowledge of tectonics is undocumented by Spanish. No chronicles discuss earthquake theory. No reports mention indigenous understanding of fault systems, yet they built earthquake-proof structures on active faults through observation and adaptation. The choice of location determined everything that followed. The engineering challenges of building on unstable ground, the water systems required to harness fault-fed springs, the need for seismic resistance after first major tremor, all from building on fractured granite over two fault lines where mountains meet. Why here? Because water flowed. Because stone was close. Because they could. Because they did. But maybe there's more. The site sits between two sacred mountains, Huayna Picchu to the north, Machu Picchu mountain to the south. The Urubamba River, Wilcamayu, or Sacred River, curves around the ridge like a protective embrace. From the Temple of the Sun, you see Mount Veronica, where sun rises on equinoxes. Look south, toward Salcantay Sacred Peak. The cosmic alignments weren't accidents. The fault location placed them exactly where astronomical and sacred geographical factors converged. Water from Earth, stone from Earth, but orientation toward sky. Maybe they chose the faults because the faults chose the sacred geography. Geological necessity, meeting spiritual imperative. The mystery isn't just engineering, it's philosophy. How do you build where Earth breaks apart? Carefully, with wisdom learned from catastrophe. And faith that dancing stones will always settle back into place. Fernando Estedi, director of the Archaeological Park, suggests landslides during construction forced creation of alternative access. The tunnel solves a mystery itself while creating new ones. How did they excavate 5 meters through granite with bronze tools? Copper tin alloy, harder than pure copper, but still softer than granite on Mohs hardness scale. Bronze rates 4 to 4.5. Granite rates 6 to 7. You can't cut harder material with softer tools by force alone, but you can with abrasion. River sand contains quartz particles rating 7 on hardness scale. Use bronze saw with sand and water. The sand cuts. The bronze guides. Tool marks inside the tunnel show parallel grooves consistent with sawing motion, but 5 meters of sawing through solid granite. Calculate labor hours. 1 meter takes estimated 100 worker hours based on experimental archaeology tests. 5 meters equals 500 worker hours minimum. More if rock proved particularly hard or tools broke frequently. The interior shows precision cutting, smooth walls achieved through abrading with progressively finer sand. Engineered ceilings sealed with carved stones fitted together to prevent water infiltration, showing they understood hydrostatics. Pressure could collapse improperly sealed tunnels, but nobody knew it existed until 2014. The tunnel sat hidden for 500 years under the most visited archaeological site in South America. 2,000 tourists walking overhead daily. Archaeologists mapping the site since 1912. But the tunnel entrance was concealed by architectural features and later landslide debris. This is the pattern. Every investigation reveals more. LiDAR finds 12 structures in 2024. Excavation finds tunnels in 2014. DNA analysis in 2023 upends population models. Seismic research in 2018 rewrites construction timelines. Each answer generates new questions. The royal tomb stays empty. The secret door stays sealed. The missing population stays missing. And the city itself keeps growing. Terraces extend beyond visible boundaries into jungle slopes where vegetation obscures Inca construction. Recent surveys with machetes clearing undergrowth found agricultural terraces 500 meters past the last known boundary. Drainage systems connect to undiscovered sectors through underground channels that still flow during rainy season. Workers clearing those channels in 2022 found ceramic fragments dating to Imperial. Period, proving the city was larger than anyone mapped. Fountains feed from springs nobody has mapped except the main one. Secondary springs exist based on isotope analysis of water samples, showing different mineral signatures at different fountains, suggesting multiple water sources. The complete picture remains incomplete, maybe always will. Conservation locks away evidence, jungle covers clues, time erodes context. Tourist pressure, over 1.5 million visitors in 2019 before pandemic restrictions, prevents invasive research in high traffic areas. But the pieces that survive tell a story. 15 people here before Pachacuti. 1,000 residents leaving 173 bodies. 50-ton blocks hauled without wheels. 500 years of flowing water. An earthquake that changed everything. Stones that cast perfect shadows. 12 new structures under trees. DNA from the Amazon and coast and highlands everywhere except here. A sealed door hiding something possibly including mummified emperor. 2 fault lines channeling water and stone. A 5-meter tunnel through bedrock. Found in 2014 after 500 years of walking past it. What else is down there? Archaeologists estimate 30% explored, 70% waiting. But conservation and stability and access all say wait. So the mysteries compound. Documented in peer-reviewed journals. Measured with precision instruments. Photographed with LiDAR and ground-penetrating radar. Tested through DNA sequencing and radiocarbon dating. published in Science Advances and the Journal of Hydraulic Engineering, and presentations at the Geological Society of America, still unexplained. That's 12 things scientists cannot answer about Machu Picchu. But here's the 13th. In 2025, a soil core sample pulled from beneath the Royal Tomb Foundation shows traces of worked metal. Not bronze, not copper. Spectroscopic analysis reveals titanium traces. Titanium doesn't occur naturally in pure form. Requires smelting at 1,668 degrees Celsius. The Incas worked bronze maxing out around 1,100 degrees. Couldn't achieve titanium smelting temperatures with known technology. The sample sits in a Cusco lab waiting for isotope testing. Results expected mid-2026. Maybe that'll explain the missing artifacts. Maybe it'll just add another question. Probably the latter. The city doesn't give up its secrets easy. Never has. Probably never will. But it keeps whispering. Through stones fitted without mortar, through bones 500 years old that tell stories through DNA, through water that still flows from fault-fed springs. The mysteries aren't failures of science, they're invitations. To look closer with better instruments. Dig deeper where conservation allows. Ask better questions based on accumulating data. And accept that some answers might be sealed behind walls we'll never open. Or buried under cities we'll never fully uncover. Or lost in knowledge systems that died with the last Quipu keepers. That's Machu Picchu, not just what we know from decades of research, what we can't know despite the best technology 2025 offers, yet. Because every few years, another discovery, another tunnel, another DNA revelation, another LiDAR scan showing structures nobody saw. The city keeps teaching, slowly, one mystery at a time.